My name's Emil. I am an AS engineer at Arista, and it's my first time at DKNOG, or indeed any kind of NOG, so I'm a bit nervous, but so please be nice to me. I'm here to talk about some network automation with Ansible, more specifically our Ansible collection called AVD. So first, just a quick agenda, a small, reason and motivation for this talk, although automation doesn't maybe need that much more motivation anymore. Like, we all know it's good stuff, right? Gonna follow it up with a quick overview of Ansible, and then go into what the AVD collection is and how it works, and then we're gonna see actually the collection in action in a couple of demos. So building a network from scratch could be considered like day zero, day one stuff, and then also deploying some services, so day two stuff, if you like to call it that. So consider this small, stupid topology of routers. If you wanted to get this to spin up some kind of VPN services on this, there's quite a lot for you to remember and to configure. Like, you have to set up your IGP, like your ISIS or OSPF. You have to set up your segment routing or your LDP or whatever it is. You have to configure your BGP relationships between the PEs. Look, I'm using the laser pointer here, and your route reflector, and all of that stuff, right? And then you have to configure your services on top of all of this. And it requires traditionally like a lot of copy-pasting stuff into the CLI windows, copy-pasting, hoping you don't make errors. I'm not saying anyone in here would ever make a typo, but except for me, maybe sometimes. Anyway, we kind of, with this AVD Ansible collection, we kind of want to do the heavy lifting for you. So you just have to worry about what services you want, and you can deploy them on your network. So real quick, although probably a lot of you are familiar with Ansible already, it's an open source automation engine owned by Red Hat. Mainly used for like server software provisioning, configuration management, stuff like that. It's very easy to extend and add functionality to Ansible with collections. It has this idea of item potency, basically meaning like if there's no change to a device, we don't touch the device unless there's a change. So if we have our playbook, we run it, we do a bunch of changes to the devices, then if we run it again, nothing happens because we've already accomplished what we want. And it runs on mainly SSH and HTTP API, like open communication mechanisms. It's got a few components. The playbooks are basically the set of instructions that you tell Ansible to go and do this, and it does. And roles are basically your pre-bundled sort of bundles of tasks, so that you can just reuse and import them as you want. Modules and plugins kind of extend how Ansible talks to devices and things like that. So then our collection here, which is called AVD, stands for Arista Validated Designs. It's made to design and stage and provision and maintain and test and document and do everything, provision your complete production networks. And we feed it, it's built on this kind of abstracted data model representation of the network that you store in your group variables as YAML. And then it generates, when you hit the playbook go, it generates the entire configuration for each device in the network. So all of the routers get their core links configured and everything, BGP and services and yada, yada, yada. It started out in life a few years ago, just mainly supporting layer 3 leaf spine, VXLAN, EVPN networks, so your basic cookie cutter DC deployment. Since then, it's gotten very, very flexible, and recently we added support for like these MPLS networks with segment routing and all that good stuff pretty recently. So, EVPN with the MPLS data plane, or you can run VPN IPv4, IPv6 address families. You can mix and match those in the same network. You can deploy your pseudo-wire services, your layer 3 VPN services, your layer 2 VPN services, etc. And it's not dependent on any kind of shady proprietary vendor software, controller software or appliance. So it's completely open source, free for anyone to use and abuse. Just spin up your favorite Linux distribution, install some open source software, and off you go. It's open for anyone to contribute to and add features. And it works very well together with our CloudVision portal. Now, CloudVision portal is not required for you to run this or any part of it, really. But it does add some value and flexibility to it. But I'm not here to sell CloudVision portal, so I'm going to skip over that a little bit. So the initial commit was 2019. Since then, we've had about 25 releases, 2,700 plus commits, 1,700 plus PRs from around 55 contributors. Those are Arista engineers as well as the customer community. And just small note, if you think the number of commits is low, it's because we squash each PR down to a single commit. And the main documentation page we have over there, installing through Galaxy, or if you're a developer or power user, you can clone it from GitHub directly. Kind of an overview of the roles, so how this thing actually works. So over to the left, we have this abstracted representation of the network in our group variables, the data model, that we then feed into our first role, which is called EOS designs. Now, what this role does, it basically generates a structured config file for each device in the topology. So basically, your CLI configuration, except it's in YAML format. And this is really nice. Some of you might ask, why not just render the CLI config directly? There's good reasons for that. Anyway, we then take that and run it through our second role, which is called EOS CLI config gen, which then is responsible for generating the CLI configuration for each device. So that's good. After this step, we just kind of have like a complete CLI configuration for each device in the network covering everything. We then use that together with the Ansible inventory with one of these deployment roles. So if you're running CVP, you're going to want to be using the CVP deployment role. If not, you can just deploy straight through the eAPI connection to the devices themselves. And the end result being that the devices are fully configured over there. Some additional stuff that this does. AVD, we kind of talked about documentation and how it's pretty difficult to keep it up to date. And we kind of propose that your automation should really auto-document your network for you. So AVD does this. It generates markdown files with fabric documentation and per device documentation as well. And it can also do automated on-demand network ready for use testing. So it can actually go out and test. And this is where we use this structured config that I mentioned before. We can use the structured config together with the inventory to go out to each device and make sure that all the PGP neighborships that are supposed to be established are established. We can check things like the LLDP topology to make sure that there are no miscablings that might be difficult to catch otherwise. We can check, I already mentioned BGP neighborships, but we can check interface states, routing tables, that all the little loopback addresses that we want are in each routing table on each node. NTP sync status, we can check the power supplies and fan status and all operating temperatures and all that good stuff. So we can do that pretty much in an automated fashion whenever you want, if you want to run it nightly or whatever, right? So demo time. Cool. You remember the topology, hopefully. This time, this happy little operator guy, it's me. You can see the resemblance, I think. It's very happy because now he has Ansible to do kind of the heavy lifting in terms of generating and coming up with a configuration and deploying it to devices. and stuff. So we have an ISI segment routing network with running the EVPN address family as the overlay. And we're going to start out with all of the devices. Now, these are virtual devices, but it doesn't matter. It works the same for the hardware. They're just virtually racked and cabled and in zero-touch provisioning mode. We're going to have a quick overview of the group variables, i.e. the abstracted network representation. I don't know how many times I've said abstracted network representation in my presentation, but a lot. Then we're going to run the playbook to deploy the network with the underlay and overlay stuff. And by that time, we're going to be done with the first part of the demo. Take a minute to take in this awesome slide. Demo 1, go. Ah, cool. Okay, so we're starting out in the Ansible inventory. This should be familiar. I hope you guys can see this, by the way. Should be pretty familiar to anyone who's worked with Ansible. We define the CVP instance, the top-level group for the network, and our different routers, hosts, RPs, RPEs, and our route reflectors, and all that. We then go into this kind of group variables where we define the basic stuff for our network. So we give it a name, we give it some TI-LFA stuff, we give it some BFD information, which BGP AS to run, and then we define our nodes. So for our P routers, for example, some defaults for all the nodes, like the platform, the loopback pools, and the node SID bases, and then some IDs and management IPs for each device. And it's much the same with the PEs, but it's a bit more because now we have some services here, and BGP, so we need some BGP defaults there, and they need to talk to some route reflector device somewhere. And then it's much the same node definition here, so we can actually also use these tags to filter which services are eligible to be deployed where. And then our route reflector is kind of simple also. And if you put two nodes in the same node group of route reflectors, they will automatically form a cluster also. Cool. Let's see. I don't think it's, yeah, it's going. Cool. So management settings, super interesting. I don't know why I kept this in the recording, but anyway. Yeah, same for this. Very interesting. And here we have the CVP instance, basically a blank slate. So what's happened here is that each of our virtual routers have gotten a DHCP lease and been like zero-touch provisioned into CloudVision. And we're just going to hop on into a router here and make sure that it is in zero-touch provisioning mode. This is how you get it when it comes out of the box from the factory. Oh, typo. I told you I was going to do typos. So anyway, this is just what it looks like when you receive it from the factory. Super interesting. And then back to CVP. So blank slate. All of the routers are in there, having received the DHCP lease. But we don't really have anything in terms of configuration for these yet. So that's what we're going to go and generate with the Ansible collection. So we just run the playbook here. And text starts scrolling. Should also be very familiar to anyone who's used Ansible, which I hope is at least some of you. As we can see, it generates what it's supposed to generate. Just having a quick look, there are no configuration objects, no tasks or anything in CVP. But God willing, there's about to be. Cool, so now it's talking to CVP, it's uploading this, yeah, you can see here it's generated a configuration for each device. So you're with your core links and your loopbacks and everything, management stuff, BGP, your ISIS protocol. all that good stuff. And now things are starting to happen here in CVP. So it's built this container topology based on the Ansible inventory groups, actually. And it is now kind of moving these devices into the container topology, and it's built these configuration objects for each device. It's attaching them to the devices, and now we get to see, yeah, the playbook has finished running. Awesome. And now we get to see what it actually wants to do. Yeep. So we're going to review the changes, and design configuration here on the left, running configuration on the right. Green is added, blue is modified, and red is removed. As you can see, we changed the BGP running mode to multi-agent. We have a lot of scrolling to do, apparently. And it's all here, the BGP stuff, the core links, the ISIS. So let's approve and execute, and this is gonna take a few minutes, mainly because the first time you deploy this stuff, you want to change the routing BGP agent to multi-agent mode. This requires a reboot, so it's gonna say that it has completed the configuration push, and it's gonna, check that the device is rebooted for a while. And also, this lab is running on my ancient home setup, so it's very slow for that reason. Anyway, it doesn't matter. Video editing to the rescue. And now, after that's deployed, we should be able to see that the ISIS adjacencies are up here. Yeah, cool. It's almost like I've seen this video before. ISIS is up. We have the routes for the loopbacks in our routing table, so the PEs here, and the route reflector, and the P nodes also. Yep. Doing the things. And then we also check the route reflector, just for good measure, to see that we have an EVPN session established to each of our PEs, and we do. But there are no services here yet, so it's quite boring. But hey, we got some of the way there, at least. So now at the end of the first demo, as I've already mentioned, the network is deployed. ISIS adjacencies and overlay BGP peerings are up, but we have no services. So there's no traffic going across the network in any shape or form. We'll go ahead and define some services in the group variables, in the abstracted network representation I've mentioned so many times by this point. We're going to run the same playbook again, so regenerating the configuration for each device, and we're going to see some services get configured and deployed, and we'll be ready for production, hopefully. These are the services we're gonna build. So we have a layer 3 VPN service running between the two sites. BGP as the PECE protocol there here on the left, and OSPF here on the right, just cause. We have a VPW pseudowire service. It's a multi-home service, and a layer 2 point-to-multipoint style service as well, also multi-homed. And we're gonna, with a little bit of help from our friends, or our AVD collection, I guess, we're gonna get these things going. So another video. And I actually wanted to do this part live, but reasons I can't. Anyway, we're gonna start by just looking in the CE devices, make sure you can see the lower layer down there on the interfaces that should be connected to the services. Then later on, we don't have our port channel up or anything to the PE. We can't ping inside of our services for obvious reasons. They're not there yet, but just wanted to show that for some reason. Anyway, network is unreachable. Cool, that's kind of expected. So here we are in our group variables again. We define the tenant, some basic information for the tenant. And then we start out with the point-to-point service, the VPWS pseudowire service. It's got a name and a type and 2 endpoints, which are basically 2 pairs of PEs, their interfaces, and some stuff to make it go, active-active, multi-homing, EVPN coolness. Then we have our point-to-multipoint service, so our EVPN straight-up VLAN, and we use the tags here to filter which sites it gets deployed to. Then for the layer 3 VPN service, we have quite a lot of stuff. So we have the VRF. We give it a name, an ID, which address family to use. So here you can imagine we could use VPN IPv4 instead of EVPN, for example. Then we have some SVIs at each site to kind of terminate this. And we could also be using like a normal routed interface, of course. And then actually at the site 1, we have a BGP, tenant BGP relationship right inside the VRF. So we define it there as well. And also, since we're talking VLANs, we need to define the actual layer 2 port channels that connect to the hosts, or to the CEs, sorry. And this is how we do that. So we define the endpoint ports, the switch ports, the switches involved, and some EVPN active stuff here as well. And just cleaning some gunk out of the file before we press play on the playbook. Apparently. Here we go. This is very exciting. Scrolling text again. It's awesome. Now we can see some stuff has actually changed for the PEs. And we should be able to see some tasks popping up here soon again in CVP. Yeah, there we go. It's happening. And here we can see this kind of item potency thing in action where it doesn't actually touch the devices that aren't changed because we're only changing the PEs. And so here, as you can see, we have a bunch of VLANs configured. We have, our VRF instances and port channels, etc., with their EVPN active-active configuration on them. Everything good. We have the patch panel where we patch the interface to the pseudowire. We have our BGP stuff here, which I'll expand soon. Any second now. Yeah, there we go. Awesome. All of the BGP stuff, so the EVPN VLANs, the VPWS instance, the the IPVRF, etc. And then your ISI stuff is the same, basically, because we already did that. And we have our OSPF instance also. This is a Site 2 PE there. So that's all good. Scrolling through it. Very nice. And then we approve and execute this again. And a little bit faster this time. So just a couple of minutes. Again, down to the slowness of my ancient home lab here. Awesome. Looks like it's a success. So now we should be able to kind of go into the CEs and verify that everything is up. So we have the interfaces are in the up state now. We should be able to ping inside, across to the other side of our service. So that's some pings going there. Great. That was the layer 2 service. We should also be able to have a look at our pseudowire service. Ping across that. Yeah, we all know if ping works, then everything works, right? You don't need anything else. Oh yeah. I'm gonna ping the gateway on our side first, for some reason. We're gonna try and check that we have some BGP routes here received on our CE device, and we have. So for the remote side network, and ping inside the L3 service here as well. Great. And now I'm going to ping an address that doesn't exist, That's why it doesn't reply. Just to, again, with the typos and everything, right? So other side looks to be responding here, so that's all good. And we're gonna hop into CE2 also. I guess we're gonna check that our BGP relationship is up, but we already know we have some routes. So anyway, might as well, while we're here and everything, established and some prefixes exchanged. Cool. We should be able to see in CPE2 here that we have our interfaces up. We should see some OSPF relationships also established to the PEs. Great output there. Hopefully a little bit better one soon. Yeah, awesome. Okay. Yeah, the routing table again. Just to check that we have some OSPF routes in there, and we do. So that's all good. And our services are now kind of officially running and active and working. And that, I believe, is the end of that demo. Yes. And also the kind of the end of my time. So if you want to discuss or reach out to me or discuss this automation or the weather or whatever, just shoot me an email. Yep. Any other questions?
We had a question on the chat, and let me just read it aloud. We have a question from Ravi from, let's see, Delta Fiber in the Netherlands. He's wondering if you know anything about the availability of multicast VPN on EOS.
Multicast VPN on EOS. I mean, this is an automation talk.
Yep.
So I don't know.
Okay. Is there any?
Ask your SE, I would say.
Yep.
Hello.
Hello.
Thank you again, Matthias from Cisco. Wonderful talk. I was just curious, the playbooks in your example, are those publicly available to peruse? I'm just personally curious how different your Ansible things are from ours, and I want to broaden my horizons. Is that also on the same GitHub, or otherwise I'll just email you if I can't find it? But
yeah, just shoot me an email. But it's on this. It's not on the same exact repo, but there are example repos, and just shoot me an email if you can't find them. But avd.sh is where we have all the documentation, and we have a bunch of examples and everything there. Thank you for having me.